is that velocity with which particle A is approaching B. So A will observe that B is going like this, like a train passing by. So again we have to calculate the minimum distance of approach. So hello everyone and a very warm welcome to LN Overseas. So I'm back with the series that is 45 topics in 45 days, right? And let me remind you, in this series we take 15 topics from each subject, summing up to of course 45 topics. And today we are going to take a topic of physics. And the name of the topic is velocity of approach or separation. Yeah, I agree that this is one of the most confused topic, right? I agree, and that is why we chose this topic today. So this is a topic from relative velocity, right? That too applied in 2 dimensions, right? So suppose you're standing on a train station, right? So you observe a train coming towards the station. So what you will say? That train is approaching. Yeah, basic. And when the train is going away from you, you say train is separating from you. Of course, that's not what you say, but you can say this thing, right? That the train is separating from you, isn't it? So how do we get this thing mathematically? Nice question you ask, and that is what we are going to discuss in today's session. So what is velocity of approach or separation? Let me just give you a statement and then we'll discuss. Velocity of approach or separation is the component of the relative velocity of one particle with respect to another along the line joining them. Okay. If I choose this as my reference line, right? Reference line. Then according to my reference line, particle B is making angle phi, right? And particle A is making angle theta. Of course, the velocities of that particle. I agree. Okay. So in ground frame, there will be certain velocity related to them. Agreed? Now, if you move to B frame means you are sitting on B and observing it. You will have a certain velocity, right? Of particle A. Suppose the velocity is like this. We say this velocity is relative velocity. Agreed? So this is your relative velocity, and this relative velocity in B frame will have 2 different components. One will be along the line joining them, yeah, depending upon this angle, right? Say this angle is alpha, and there will be one component that will be perpendicular to the reference line. So velocity of approach or separation is this component, the component that is along the line joining them. Right? It is that velocity with which particle A is approaching B or it is separating from B. Right? So how do we say it is approaching or separating? That is basic common sense. So if particle A is moving away from B, you will say it is separating. So I will use the term as velocity of separation. Right? And if the particle A is in the opposite direction, that means it is going towards B. If I am sitting on B, the particle is coming towards me. That means that particle is approaching me. That means I will say that this is velocity of approach. Right? Again, I will remind you that this is that component that is along the reference line or along the line joining them. Getting the point? Easy, no rocket science. Okay, let us see how to get the mathematics. In the ground frame, what is the velocity of B? This thing will be equals to VB sin phi. This thing will be equals to VB cos phi. This will be equals to VA cos theta. This will be VA sin theta. If I choose my reference like this, my reference is something like this, right? This is my positive x and this is my y, right? So what is velocity of A in ground frame? That is velocity of A cos theta I cap plus VA sin theta j cap. VB will be equals to VB cos phi I cap plus VB sin phi j cap. Basic. What will be the relative velocity? Let us see. Velocity of A with respect to B. Yeah, right. You can choose other way around as well. Velocity of B with respect to A as well. But let us consider this case. So this is VA minus VB, right? VA minus VB. VA minus VB. So this thing will be equals to VA cos theta plus, or say minus, let me write here only, minus VB cos phi I cap plus VA sin theta minus VB sin phi j cap. Check. Agreed. What will be the component, right? This is the relative velocity, right? What will be the component along the line joining them? So that is along x-axis, right? So I cap 1, absolutely. So I cap 1 will be the component. Now if this thing, this component is positive, according to my convention, this is positive. That means VA cos theta, right? If this is positive, means VA cos theta is greater than VB cos phi. That means this velocity is greater than this velocity, right? That means A is running away from B, right? Velocity of B is less in this direction along the line joining them. So B is lagging behind, A is running away. B is never going to catch it. That means this is separation, right? A is going away. So this is separation. And if this is negative, then VA cos theta is less than VB cos phi. That means B is moving more in this direction than A. That means B is going to catch A. So if you are in B frame, you will observe A, that A is coming towards you. Getting the point? Yeah. So in this case, A is approaching B, right? So this is the case of separation. This is the case of approach. Agreed? Clear? Nice. Okay. Moving ahead. Let us talk about one more thing, and that is the minimum separation. Suppose we have two particles, again A and B, right? A is trying to move like this, B is trying to move like this, right? In ground frame. Okay. What about A frame? Do you agree that B will move like this? Let us see it once, how it will move. Like this. Again. Like this. Right? So A will observe that B is going like this, right? A train passing by. Basic. Okay. Nice. Now, let us analyze this thing. So B is passing by like this. According to A, right? In A frame, B is going like this. Okay. Moves to this point. This point is of my interest. We'll see. Then it moves away. Something like this. Okay. That means when the particle is here, or say when the particle is at the beginning, there is one velocity like this and one velocity like this. Right? Yeah. So how can you say this thing? So A was going like this, right? In ground frame. Let us check. In ground frame, say this is Z frame. This is A, this is B. In ground frame, A was going like this, B is going like this. Suppose velocity is VA, velocity is VB. So in ground frame, this is VA j cap, and in ground frame, VB will be VB say I cap. This is positive. Okay. What will be velocity of B with respect to A? That is velocity of B minus velocity of A. That is velocity of B is VB I cap minus VA j cap. I cap minus j cap. So I cap minus j cap. That is why I am saying that the particle is going like this. That's how you have to realize it. Agreed? Okay, the particle is going like this. We agree with you, sir. Now, at this point, there will be two components. Again, say this component is V parallel, this component is V perpendicular. Yeah. At this point, again, what will be the component along the line joining them? That will be V parallel, and this will be V perpendicular. Are you sure? Check again, right? Take some time. Till then, consider this thing. The particle is moving away. So along the line joining them, velocity, parallel velocity will be like this, right? And perpendicular velocity will be like this. Here, the V parallel is along A. Here, V parallel is away from A. So do you agree that there will be one point where it is neither approaching nor separating? Do you agree that this complete region is of approach? The particle is approaching. This complete region is of separation. Do you agree that at this point it is neither separating nor approaching? Yeah, basic, no rocket science. So it is neither approaching nor separating. That means at this point, the particle will have minimum distance, right? Particle will have minimum distance of approach, right? It is approaching till this point, then it gets on separating. So when the distance between the two particles will be minimum, well, it is neither approaching nor separating. No rocket science, right? Yeah. Sounds right. So now we are interested in this thing only, right? These are the two cases that we have seen. This is approach region, this is separation region. This is the minimum distance of approach. Now, if I calculate this velocity, I can calculate this angle as well, say this angle is theta. Now, if I know the distance between these two particles, I can easily determine d minimum. I can, right? So, my first aim is to realize that where the particle is going with respect to any other particle, where particle B is going with respect to A. That is the first objective that you have to complete. Then, get the angle, get d minimum. Confusing? Let us take a question. Two projectiles P and Q are projected simultaneously in vertical xy plane from the same horizontal level as shown in figure. The minimum distance between these projectiles during their motion is. So again, we have to calculate the minimum distance of approach. How? Let us see. First, calculate the velocities in ground frame. Okay. So what is velocity of Q? Okay. Suppose this is my axis, this is my x-axis, this is my y-axis. So velocity of Q will be minus 5 root 2 cos 45 I cap. Y minus x is positive, x is in this direction. So there will be one component like this in the negative x direction. There will be one component like this in the positive y direction, right? And that component will be 5 root 2 sine 45 j cap, positive. So this is minus 5 I cap plus 5 j cap. Everything is in ground frame now. Okay. Next, we have velocity of P. Velocity of P is 10 j cap only. Simple. Okay. Let us move to P frame first. Right? P frame. So in P frame, what is the velocity of Q? Velocity of Q minus velocity of P? Yeah. What is velocity of Q? That is minus 5 I cap plus 5 j cap minus 10 j cap. So this thing is minus 5 I cap minus 5 j cap. Agreed? So now we move to P frame. That means if I draw P and if I draw Q, Q is moving in direction minus 5 I cap, right? And minus 5 j cap, that means down somewhere here. Agreed? Yeah. So if that is the case, this is the line joining them, right? Yeah. So where is the velocity of this particle? The particle will be moving like this. When we get the minimum distance, when particle is neither separating nor approaching, when it is perpendicular, right? When, as seen from P, the particle is perpendicular to the trajectory. So what is the second step? Drop a perpendicular over the trajectory. Yeah. So this is your D minimum. Agreed. What is the distance between them? 10. This is 10. What will be this angle? Minus 5 I cap minus 5 j cap. Sir, angle will be 45 degrees. Yeah, that is 45 degrees. I agree. Basic. So this is 45 degrees. So what will be D minimum? Sir, from geometry we can say that this thing is 10 sine 45. This thing is 10. This is perpendicular. This is hypotenuse. This is perpendicular. So this perpendicular will be equals to hypotenuse times sine 45. Right? So this is 10 by root 2 or 5 root 2. Basic, no rocket science. I analyze the same thing, but in Q frame. In Q frame, this is P, this is Q. Let us move to Q frame. What is velocity of P with respect to Q? What was velocity of P? What was velocity of P? Sir, P 10 j cap, right? And this was minus 5 I cap plus 5 j cap. So do you agree this thing will be equal to 5 I cap plus 5 j cap? That means with respect to Q, P is moving like this, right? Positive 5 I cap, positive 5 j cap. Yeah, agreed. Distance between them 10. Drop a perpendicular from Q. This is your D minimum. How much will be D minimum? This angle is again 45 degrees. This is 10, this is 45. This will be 10 sine 45 or 10 by root 2 or 5 root 2. Yes or no? So this is the general approach we take, geometrical approach. Can we solve this thing analytically? Let us see. Let us assume the Q frame only, right? In Q frame, let us see what is happening. So this is Q this is P, right? Can I get the instantaneous position of P with respect to Q? Select the reference first. This is my reference. Suppose this is X, this is Y. I can do that, right? Now, P was moving like this, isn't it? If I have to write X position of P, right? This is 5i cap, this is 5j cap. So the initial position x naught, x is equals to x naught plus ut, isn't it? So x naught is 10, right? Initial distance 10. Minus, why minus? Because now velocity is in the opposite direction. Minus 5 into t, right? Suppose this is x. Do you agree this is the x coordinate? Yeah, take your time. 10 initial distance minus 5t, why? Because velocity is in the opposite direction according to my reference. Yeah. What about y? So that is in the positive direction. No problem in that. Right. So this thing is 5t. So if I say that this coordinate is x comma y at any particular point, so that what will be the instantaneous distance? This is 0 comma 0. This is x comma y. The instantaneous distance will be basic under root of x squared plus y squared. So this thing will be equals to 10 minus 5t squared plus 5t squared. Agreed? Now, what I have to achieve now? So minimum distance. Minimum distance. So minimize this thing. Yeah, we know how to minimize this thing. dd over dt must be equals 0. So differentiate this thing. Differentiate this thing. This will be 1 over under root of 10 minus 5t squared plus 5t squared, whatever is there, times, apply chain rule. This will be twice of 10 minus 5t times minus 5 plus twice of 5t times 5, right? This thing must be equal to 0. Chain rule. So can I take this thing, right? This is complete line. This thing will be 0 on the other side. This 5 will be gone. This 2, this 5, this 2, right? Just drop this 1. This is not 12. This is 1 only. This 2, this 5, everything is gone. So what is left? That is 10 minus 5t times minus 1 plus 5t is equal to 0. So this will be 5t minus 10, 5t, 10t. 10t is equals to 10, which means t is equals to 1 second. Ah, that's nice. T is equals to 1 second. That means at t is equals to 1 second, the distance is minimum, right? How do you know this is minimum? You can check, get the second differential. You can check it must be greater than 0 at 1 second, at t is equals to 1 second. So if that is the case, substitute this thing back to this thing. So if I substitute t as 1, so this will be 10 minus 5 squared plus 5 squared, right? So this thing will be equals to under root of 5 squared plus 5 squared or 5 root 2 meter. Agreed? Yeah. Analytical approach is also there, right? Geometrical approach is also there, but that approach is generally preferred over this thing, right? But you must know every tactic that is available, right? Okay. So that's how we get the minimum distance of approach, and that is the concept of velocity of approach and separation from my side for today. So it was really nice being with you all. I hope you have enjoyed this session with me. The complete link to the playlist is available in the description. If you have any queries, any doubt, you can drop them in the comment box. Bye bye. Have a great day.